Welcome to our exploration of marine ecosystems at risk, understanding ocean acidification. In this video, we will delve into the science behind ocean acidification, a growing threat to marine life and ecosystems. We will discuss its profound effects on shell-building creatures and coral reefs, examine its implications for marine food webs and fish behavior, and highlight the economic consequences tied to these changes. Join us as we uncover the intricate connections between global carbon dioxide levels and the health of our oceans, and discuss potential pathways to reversing the damage. 1. What is ocean acidification? Ocean acidification is a process that occurs when our oceans absorb excessive amounts of carbon dioxide, CO, from the air. This might sound like a chemistry lesson, but the reality is far from academic. As carbon dioxide levels in the atmosphere rise, largely due to human activities like burning fossil fuels, oceans act like giant sponges, soaking up this gas. The absorbed carbon dioxide reacts with seawater, leading to increased acidity. Imagine adding lemon juice to milk, it curdles, right? Similarly, the ocean's chemistry is altered, with far-reaching consequences for marine life. This change is not just a drop in the pH scale but a significant shift that threatens the delicate balance of marine ecosystems. 2. Effect on shell-building creatures. Marine animals that rely on calcium carbonate to build their shells, such as corals, oysters, and clams, face a tough battle. Acidic waters make it difficult for these creatures to form and maintain their protective shells. It's akin to trying to build a sandcastle with wet sand. The structure just doesn't hold. The weakening of their shells leaves these creatures vulnerable to predators and environmental changes. Some species may even struggle to survive, leading to a decline in their populations. This is more than just a concern for marine biologists. It affects the entire underwater community and, consequently, the human communities that depend on them. 3. Threat to coral reefs. Coral reefs are often called the rainforests of the sea, due to their incredible biodiversity. However, they are particularly vulnerable to ocean acidification. As the water becomes more acidic, the calcium carbonate structures that form the backbone of coral reefs weaken. This is like a sturdy building slowly crumbling from within. Weaker coral structures mean less habitat for the myriad of species that call reefs home. The loss of coral reefs would not only mean losing one of nature's most beautiful spectacles but also the disappearance of crucial habitats that support a wide range of marine life. 4. Impact on marine food webs. The effects of ocean acidification ripple through the marine food webs. Tiny organisms at the base of these webs, like plankton, are affected by changes in water chemistry. When these foundational species struggle, the impact is felt all the way up the food chain, affecting larger predators like fish, seabirds, and marine mammals. It's like removing the foundation of a building. Everything above it is at risk of collapse. This disruption can lead to imbalanced ecosystems, where some species may thrive while others decline, ultimately affecting biodiversity and the health of our oceans. 5. Fish behavior changes. Fish are not immune to the impacts of ocean acidification. Some species exposed to acidic conditions exhibit changes in behavior, such as difficulty in detecting predators or navigating their environment. Imagine trying to find your way through a foggy forest. You might struggle to see the path or sense potential threats. For fish, this can mean a higher risk of predation and challenges in finding food or mates. These behavioral changes can have long-term effects on fish populations and the ecosystems they inhabit, further highlighting the far-reaching consequences of a more acidic ocean. 6. Economic impacts. The economic implications of ocean acidification are significant, particularly for communities that rely on fisheries and aquaculture. As shellfish populations decline due to weakened shells, the seafood industry faces potential losses. This is akin to a farmer losing crops to a drought. The economic impact can be devastating. Many coastal communities depend on fishing not just for food but as a primary source of income. The threat to marine resources poses a direct risk to livelihoods, underscoring the urgent need to address ocean acidification for both environmental and economic reasons. 7. Global carbon dioxide connection. The connection between global carbon dioxide levels and ocean acidification is clear and undeniable. Human activities, such as industrial processes, deforestation, and the burning of fossil fuels, contribute significantly to carbon dioxide emissions. This, in turn, leads to higher concentrations of carbon dioxide in the atmosphere and, consequently, more acidic oceans. It's a chain reaction where each link is critical. Understanding this connection is essential for addressing the root causes of ocean acidification and taking meaningful action to mitigate its effects. 8. Reversing the damage. Addressing ocean acidification requires a two-pronged approach: protecting marine ecosystems and reducing carbon emissions. Efforts to safeguard marine habitats, such as establishing marine protected areas and promoting sustainable fishing practices, are vital. At the same time, reducing our carbon footprint by transitioning to renewable energy sources and enhancing energy efficiency is crucial. Picture it as patching holes in a sinking ship while also stopping the water from pouring in. Together, these actions can help reverse the damage, ensuring a healthier future for our oceans and the myriad of life they support.